What is up, math magicians? This is section 3.4.2, solving quadratic equations and by factoring. And today, a is not going to equal 1. Well, first of all, I just want to say that we're going to start off looking at these steps. And we've got to remember this process here. Last video, we set things equal to 0. We took a GCF. We found the GCF. We split the middle. And by splitting the middle, I mean we list the factor pairs of the C term. We chose the pair that adds up to B. Then we box factored, which helps us reverse the FOIL. We split the equation with a zero product property, and we solve the individual equations. Now, if it ever says to just factor, then we can do the same thing and not do the first 5 steps, and not do step 6. So today it's just going to be a little bit of an extension. What happens if you have this? You might notice the thing that's different is that there's an a value here, a. So we're going to use this. We're going to slightly modify this process if a is not equal to 1. In all the previous examples, it was just x squared. You see x squared here, u squared here, v squared here. It wasn't 3v squared. It was just v squared. So today what this looks like is here we're going to do the same thing. We're going to start off by just saying that it's all set equal to 0 and the GCF is equal to 1. So what we're going to do is not just look at the factor pairs of 10. We're actually going to use 3 times 10. This is the AC method. It lists all the factor pairs of AC. So and a is the value in front of the x squared. So 3 times 10 is 30. So we got factor pairs 1, 30, 2, 15, 3, 10, 5, and 6. And so then, we can see that 5 and 6 also happen to add up to 11. So great, now we have our two values, 5 and 6. That means we can split 11x up into 5x and 6x. And now we're going to box factor. We'll put 3x squared here, 10 here, and then these two are kind of interchangeable. And we find the greatest common factor of the top row, it's x. The bottom row, 2. The left column is 3x, and the right column is 5. That helps us group these into two different factors. 3x plus 5 times x plus 2 equals 0. Zero product property says we can split them up, and then we can solve the equations individually, and those are our two answers. Great. Let's do this again. It's going to be a very similar process. We just have to make sure we multiply the a value, which is 5, times the c value, which is negative 12. Of course, first we check to make sure that the equation is set equal to 0. The greatest common factor is equal to 1. And so therefore, I got to multiply 5 times negative 12, which is negative 60. Wow, okay, so what are the numbers that multiply up to negative 60? There's a whole lot of them, and I don't think I can fit them in the screen, but I just did notice that negative 2 times 30 does equal positive 28. So I can split positive 28x into minus 2x and 30x. All right, so then we get box factor. 5x squared goes here, negative 12 goes here, 30x and negative 2x. So then we've got the top row, GCF, the bottom row, GCF. The left column, 3x, and the right column, 5. Those are the GCFs. So that means that x plus 2 times 3x plus 5 must be the same thing as this factored. And if it ever asks you to factor that without the equal 0, you can just box factor and produce what's on the left-hand side of this equation. But if it's an equation form, then you got to keep going. You got to split it up using the zero product property, solve the individual equations using your algebra 1, and then you get your solutions. And negative 6 should work back in here. So 5 times negative 6 squared plus 28 times negative 6 minus 12 should equal to 0. And it does. All right. First step, it's already set equal to 0. We find a GCF of negative 10. I'm going to choose. I could have chosen 10 to divide all the terms on both sides by, but I'm going to choose negative 10 because my preference is to keep this a value positive. So when I divide by negative 10, this divided by negative 10, this divided by negative 10, this divided by negative 10, and 0 divided by negative 10, we get 6x squared minus 5x minus 4. Great, the AC value, 6 times negative 4, is negative 24. And what are the factor pairs of negative 24? Here they are. There's a whole lot of them. I'm just going to, I see that negative 3 times 8, negative 8 times negative 8 times 3 is negative 24, and negative 8 plus 3 is negative 5. That's the b value here. So I can split up minus 5x into minus 8x plus 3x, as you can see right here. We got that box factor going on, so we got, so we put them all right here, and the greatest common factor of the top row, greatest common factor of the bottom row, greatest common factor of the left column and the right column, and we get 3x minus 4 and 2x plus 1. There it is. If you were to FOIL these out using a box, you would put them on the outside, and then you'd FOIL them on the inside, and then you lay them all out. And this is foiling would be going from this up to this, but we're reversing the foiling. All right, so we got 3x minus 4 and then 2x plus 1. And you can split them up using the zero product property and then solve them individually, and you get these two numbers. Great. Next. Let's see. One more example. Oh, wait a minute. It is not set equal to 0. I've got x's all over the place, both on the left-hand side and the right-hand side. So I'm going to subtract x squared minus x from both sides, and I get 3x squared minus 8x plus 4 equals 0. Greatest common factor seems to be 1. So, minus 8x. Oh, sorry. 3 and 4. I'm going to multiply the 3 times the 4 to get negative 12. Positive 12. And so what are the factor pairs of positive 12 that add up to also to negative 8? Well, I could do all these positive versions, but in order to get them add up to negative 8, I have to go negative 2 times negative 6 does equal positive 12, and also happens to add up to negative 8. So I can split up minus 8x into minus 2x and minus 6x, like this. You put all four of those terms in the box factor like this, and then you find the four different GCFs. GCF on the left is just going to be positive 3x. And then notice here, in order for this to be x, I have to say negative 2 times x is negative 2x. I have to make this negative as well. And negative make a positive here. So they can split this up. Write the x minus 2 and the 3x minus 2 here, and then split them up. 3x minus 2 equals 0, or x minus 2 equals 0. And so then we have x could be 2/3, or x could be you tell me. Let's reverse the process. We did this before. Write an equation whose solutions and leading coefficient are given by x equals 3 and x equals negative 1, with a leading coefficient of 2. Well, we've seen this before in last class with just x equals 3 and x equals negative 1. What you have to do is you have to solve this, unsolve it, so subtract 3 from both sides and add 1 to both sides. You get x minus 3 equals 0 and x plus 1 equals 0. Combine the two with using the zero product property, and if you want a leading coefficient of 2, you can put a 2 out in front of here. So that when you basically have 3 different things you're multiplying: this times this times this. And so you can multiply them in whatever order you want. These 3 different things. Maybe the first 2, do this multiplication first, or do this multiplication. If you do this multiplication, it looks more like foiling, and then you double. You get these, and then you can multiply here and distribute, and you get your answer right here. This is an equation that has as its solutions 3 and negative 1, and has a leading coefficient of 2. This x squared term is 2. That's what the leading coefficient is right here. Let's see. If x is equal to negative 5 and x equals 0, and the leading coefficient of 4, then I want to add 5 to both sides, and I get x plus 5 equals 0. Combining the two, you get x plus 5 times x, and then you can distribute, and you get 4x squared plus 20x. All right, let's talk about some SAT topics. So identities. What is an identity? An identity is the equation that is true for all values of x. So, for example, let's check to see, is this an identity? Is 3 times a number equal to the same thing as 2 times a number plus that number? Yes. We can see the 3x, if you combine the right-hand side algebraically, and then you can even subtract 3x from both sides, you get 0 equals 0. This is a true statement, so therefore the original is an identity. Yes. The answer is yes, it is an identity. Over here, if I'm wondering, is x plus 1 squared the same thing as x squared plus 2x plus 1? And in fact, if you FOIL this out, x plus 1 times x plus 1, you do get the left-hand side. You can subtract x squared plus 2x plus 1 to both sides. You get a true statement. And so therefore, yes, it doesn't matter what value you choose for x. This equation is going to work. That's what an identity is. So 4x squared minus 81. Is that the same thing as 2x plus 9 times 2x minus 9? Well, if you FOIL the right-hand side, you get this. You add 81, you subtract 4x squared, you get 0 equals 0. They're the same equation. So the same expression on both sides, and that's an identity. It doesn't matter what value you choose for x, this equation is going to be true. What about this one? Subtract 3x squared from both sides, and then you get 5 is equal to negative 6. That's a false statement. No. So this is not an identity. It is not true for all values of x. So what could this look like on the SATs? Here's a screenshot of a SAT question. It says, this is going to be tricky, so hang with me. If ax plus 2 times bx plus 7 is equal to 15x squared plus cx plus 14, for, everyone say it with me, for all values of x, that means identity. And a plus b equals 8. What are the two possible values for c? Whew, what is going on? There's so many letters here. I don't know what to do. Well, let's get curious and play around with it. I don't know. Let's get rid of the parentheses. I think we can FOIL this, can't we? Sure, well, foiling this, that's what this would look like. So if you FOIL this, it would be ax times bx would be ab. Collecting the x's, you get x squared. And then for the outside terms would be 7ax. And then the inside terms would be 2bx plus 14 is equal to 15x squared. Somehow that's going to be, this is true for all values of x. What are the two possible values of c? Alright. Well, what we can do is, actually, I notice that there's an x term here and an x term here, so I'm going to collect the x terms, and now I get 7a plus 2b is equal to what used to be this. Like if you distributed, you could get back to the original, but I'm factoring. I found the greatest common factor, which is x. So it looks like if you're going to make this true for all values of x, if it's going to be an identity, then the left side is going to have to look like the right side. The left side here looks like the right side here. That's what an identity looks like algebraically. That means this abx squared has got to be the same thing as 15. And this 7a plus 2b has got to equal to c. So I know these two facts. I know that a times b is 15, and I know that 7a plus 2b is equal to c. I also happen to know that a plus b equals 8. So if a plus b equals 8, then the two, so you give me two numbers that multiply up to 15 and add up to 8, well, that's going to be 3 and 5. Or it could, you also have it switched around, or it could be 5 and 3. So if a and b, so let's use these two possibilities to find out what c are. So I know that 7a plus 2b equals c, so therefore 3 times 7 is going to be 21, and 2 times 5 is 10. Add them up, you get 31. C, in this case, c is 31, and in this case, c is 41. And those are the two answers. Boom. So I'm going to mark answer choice D. Let's do that again. Let's see what this could look like. In the equation above, a, b, and c are constants. If the equation is true for all values of x, that's identity. That means the left side is going to have to look like the right side. What is the value of b? Well, I see a whole lot of parentheses here. I guess one thing I could do to play around with it a little bit would be to distribute. So if you distribute this and distribute this, we get this here. Collecting the terms, 6x squared plus 19x plus 15 is equal to ax squared plus bx plus c. Oh, well, then we go. What is the value of b? That would be this term right here, which is 19. B is equal to 19, and you can report that the answer is 19. I can also report that my favorite sandwich is a turkey Diablo. I've only ever had it in one sandwich shop in my college town of Bethlehem, PA. This goes out to the Goosey Gander. They make the best turkey Diablo. So if you're ever up there, tell them Berg sent you. Take care, and I'll see you in class.